Okay, this is the first video in our Chapter 10 special series, if you will. So you probably noticed the course calendar says Chapter 10 Special. This is because we're going to cover a few topics from Chapter 10, but skip most of what's in Chapter 10. The topics that we are going to cover are spread through pretty much the whole chapter. The Chapter 10 homework in my math lab is just the problems that we're going to do. So what I'm going to do in these videos is talk about how to do some of the different types of problems that are in the Chapter 10 homework, all right, assignment. So the first main category of stuff we're going to do is linear systems. So we're going to talk about solving systems of linear equations. There's three types. In terms of the way they work out, there's three different ways. The first is independent. These systems have one unique solution, all right, one solution. If you graph them, the solution would be a single point where all the lines intersect, okay? Dependent, these systems have an infinite number of solutions, okay? So typically if you graph them, maybe two of the lines are the same line somehow, or maybe in a three-dimensional case, it's actually a whole plane of solutions even. It's kind of crazy. But typically, the most common way you get dependent is an infinite number of solutions because somewhere there's a line that every point on that line is a solution to the system. Inconsistent means do not have a solution, no solutions, all right? So the reason they're saying inconsistent then is this just what they're giving you here doesn't even work out. Okay, so let's start with 2 by 2 systems. So 2 by 2 means 2 equations and 2 variables. All right? 2 equations, 2 variables. There's 2 basic methods. The first one is substitution. You can always use either method. Typically, though, if you've got one of the variables pretty much set up, like see you just have y by itself there, that, a lot of times you might want to do substitution. You don't have to, but it works out that way. So let's take this, we're going to do substitution. I'm going to take this first equation, and I'm going to add the y over to the right. So then I'm going to have 3x equals y plus 3. Then I'm going to subtract the 3 back over here. 3x minus 3 equals y. All right? So now I know that y equals this right here, this 3x minus 3, right? So what I'm going to do is I'm going to substitute that in for the y in the other equation. So the other equation is 4x plus 4y equals 20. And then I substitute in the 3x minus 3 for the y plus 4 parenthesis 3x x minus 3 equals 20. Then we get 4x plus 12x minus 12 equals 20. So add the x's together, I get 16x minus 12 equals 20. All right, add the 12 to both sides. 16x equals 32. And then dividing both sides by 16, x equals 2. All right? So I know x equals 2. I'm going to plug that right back into this equation right here. So 3 times 2 minus 3 equals y. 6 minus 3 equals y. Y equals 3, right? So I know x equals 2, y equals 3, and my solution then is 2 comma 3. Okay? So that is substitution. Let's look at elimination. Now you notice this time I don't have anything that's just a single y, right? What we have is 4x minus 6y equals 3 and 7x plus 3y equals 3. So what we're going to do is, when you say elimination, is you're going to try to set up by adding the 2 equations together to eliminate one of the variables. But usually you have to make some sort of adjustment so that when you add them together, one of the variables will get eliminated. So look at this right here. You see the 6y is twice the 3y, but it's the opposite sign, right? So what I'm going to do is I'm going to take this whole second equation and I'm going to multiply it by 2, all right? So I'm multiplying both sides of the equation. So 14x plus 6y equals 6. Okay? All right? Multiply both sides of the equation by the same thing, doesn't change anything. And, okay, so that's kind of in the way there. So then the other equation, we'll just recopy 4x minus, this is a y, minus 6y equals 3. Right? So I have my new version of equation 2 here. I just multiplied both sides by 2. I have equation 1 here. Now if I just add them, all right, 14x and 4x is 18x. Plus 6y minus 6y is 0 and 9. This is why they call it elimination. The y gets eliminated. Divide both sides by 2, or actually divide both sides by 18. X equals 9 over 18. X equals 1/2. All right. So now I have x. This one's a little less friendly because x was a fraction, but that's not the fault of elimination. That's just these equations. So I can take this x equals 1/2 and plug it back into either equation. I'm going to plug it into the first one. 4x minus 6y equals 3. Now put a half in for x. 4 times 1/2 minus 6y equals 3. 2 minus 6y, right? 4 times a half is 2 equals 3. Let me subtract 2 from both sides. Minus 6y equals 1. Divide both sides by minus 6, y equals minus 1/6. So my answer for this one then is 1/2 comma minus 1/6. There's my answer. Okay, so this was elimination, where you multiply one, or sometimes maybe you have to multiply both equations by something, so that when you then add the result together, either the x's or the y's cancel out. Okay, and they get eliminated. Like this time we just had to multiply the second equation by positive 2, and that then created a situation where when we added it to the first, it was eliminated. Both of these methods, elimination and substitution, can be used on pretty much any system. They're generally used more on 2x2 systems, and then again on the nonlinear systems, which we'll come back and see that later. Now on the larger systems of linear equations anyway, okay, so for larger systems, we're going to do 3x3, but the methods we're going to use can be used for much larger than that. All right. For larger systems, we have a couple of different methods we're going to use. We're going to do both methods on a calculator. TI-83 or 84 will work. I have some stuff in here to show you how to do it exactly on one of those two. If you have a different type of calculator, then that's a graphing, I'm sure they'll do it too. You just have to find from your user's manual or whatever how to do it. The first method is called Gauss-Jordan elimination. All right. So this method uses something called an augmented matrix. Okay, augmented matrix. And then Gauss-Jordan elimination to rewrite the matrix in something called row reduced echelon form. You see the RREF, abbreviated RREF. So we will write the system as an augmented matrix. Right, there's that term again. We'll write it as augmented matrix, and then use our calculators to put it in this row reduced echelon form. The calculator has a command that's literally RREF. Okay, so the first step is to take a system and write it in the augmented matrix form, which is pretty simple once you see it. Like for example, here's a system right here. Okay, and all we're going to do really is we're going to write down all of the numbers, all the coefficients on one side, and then a vertical bar where the equal signs go, and then the constants, right? So this first equation is 1 minus 1, 1, and then we get to where the equal signs are, so I'm going to draw a vertical bar through all three lines, and then 12. Second system, there's no x, so there's a 0, and then 4, 4, 4. Third equation, 1x, 1y, 5z, and a 3. There's the augmented matrix, that's it. All right. Now, as the next step here, I clipped it here, all right? I'm not sure actually going to be able to use it in the video, but it is also, as you'll see, right after the link for the video, right after the link you click to get into this video, you'll see this exact link there, and it will take you to a document, okay, that will show you how to use this RREF command to on an augmented matrix. All right, so that's it for the first video.